Hi, this is the lesson for Monday, March 30th. Um, our lesson today, we're going to talk about some ionic bonding and some ions. So let's go ahead, we'll label this in our notes, ionic bonds. You're going to need your notes and you're going to need a periodic table. So if you do not have a periodic table in front of you, please pause the video. You can either open up a periodic table on your Chromebook, your phone, or a paper copy. All right, so take a moment, get all your stuff. We'd already copied down a version of this chart, and some of you may have it. It's in the periodic trends packet. But for those of you that don't have that available or you're not quite sure where it is, we're just going to write down the group numbers and the number of valence electrons they have and their charge. So we're going to have three columns in our chart. So we have group number, valence electrons, and ion charge. This chart is going to be pretty handy when you are learning how to write ionic compounds. And this is something that you're going to do tomorrow. So your chart for today, we will have group numbers. Let's do 1, 2, 3 through 12, and 13. Okay. So essentially, group numbers 1 through 13, these are all a particular style of element. These are all classified as metals. All right. Number of valence electrons. Group 1 has 1 valence electron. Group 2 has 2. Groups 3 through 12 have 2. And group 13 has 3. Okay, so that's something you should already know. The group numbers correspond to the valence electrons. Over here with the charges, their ionic charges are 1 plus. So this would be like lithium plus. And if you don't see a number in front of it, you can assume that that number is a 1. Group 2 is a 2 plus, like magnesium 2 plus. And these numbers should look pretty familiar to the showing the bonds with how many valence electrons they're giving up. The ionic charge for 3 through 12 varies. It varies based on what it is going to bond with. All right. And then, but it's always going to be positive. And then group 13 is going to have a positive charge of 3, like Al 3 plus. Okay. All right. I'm going to switch colors. We're going to go to group 14. Group 14 is special because sometimes it participates in ionic bonds and sometimes it doesn't. It depends if what you're talking about in group 14 is a metal or if it's a metalloid or a nonmetal. So it has 4 valence electrons, and if it does ionic bonding, it's going to have a charge of 4 plus, or it might vary. We'll talk about how you can figure out if it's going to vary. Sorry, it should be 1R. All right, moving across the table, our next ones are groups groups 15, 16, and 17. Okay, So their valence electrons also correspond to their group number. So we have 5, 6, 7 valence electrons. And here's where that change in the charge flips. It's not what they want to get rid of. These are what number of valence electrons do they need in order to become stable. So if you're in group 15, you need 3 more negative charges. Because remember, the magic number that we're trying to get to is 8. So something might be like P3 minus. Group 16 has 6 valence electrons, so it needs 2 more to reach that magic number of 8, like O2 minus. Group 17 needs 1, like F minus, or if you need to see the 1, write it. And these guys in 15 through 17, these are our non-metals. All right, so right now you should be noticing that metals have a positive charge and non-metals have a negative charge. Okay. And then lastly, we have group 18. And group 18, with the exception of helium, has how many valence electrons? 8, which makes them completely stable. And there are no ions formed by this group. That's where we're going to stop today. Please make sure that you copy this down in your notes. Thank you.